The thing is, developers have deadlines, developers need to get stuff out fast. Sometimes corners get cut, and often security is part of that set of corners. And for security professionals in the audience, hands up. A few, okay. Some are both, this is good. For security professionals, you can't just go tacking a security stage on the end of one of these here. You probably go sort of thinking of sticking it either there, or right about in that release cycle. Because if you try doing that, then a developer who is on a really tight deadline may try going around you. And the one thing that we can't be as security professionals anymore is the abominable no man. So we need to ensure that security is built into every single one of these stages, and it's also an interesting balancing act that you need to make to ensure that the security you build in isn't so onerous that your developers complain or try using third-party tools that you might not like them using instead. We want to actually set things up and maintain the balancing act so that the desirable way to do something is also the secure way to do something. And my view about people who decide that they want to go using third-party tools or external sites that may not be security sanctioned is, okay, so they're being creative. You're never going to stop them doing that, because developers are also very cunning people. So the best way to actually ensure the developers use the tools you want them to use is to give them tools that are better than what is out there that they may want to use otherwise. Give your devs the best tool chain, look after them, they will look after your security. So, to actually move on to CI/CD from the point of view of putting security into dev, we have a few things to look at. Would you say, if I show you this slide, would you say, hands up if the answer is yes, this bears an approximate relationship to the CI/CD tool chain that you already have, or if you haven't deployed one already, are looking to use? Hands up, please. Just a couple. Okay, for the rest of you, it would be great to have a chat afterwards. I am available all day and probably tomorrow morning as well about what's different between this and what you're already running. But anyway, if you look at this diagram and then put your security tinted glasses on, this is where you actually have the opportunity to integrate different security technologies into different stages of your development and integration and development and deployment process. And really, I'm going to be using this as the agenda for the DevSec piece of this session. So if we start at the top with actual validation of the code that developers may be writing, there's a few things that you want to look at here. We've all seen things happen with customers who have, for one reason or another, mishandled static AWS credentials. So this typically happens by them accidentally posting them on GitHub, built into code that they have gone unpublished. If you want to go preventing that, there's a few options. There is tooling out there from third parties that claims to be able to do this. We found that some of it delivers better than others, so we wrote our own tool, Git Secrets, which is available in the AWS Labs account on GitHub. So if you use this as a Git hook, it will stop any pushes to GitHub, just essentially doing a regex scan of your source code to look for anything that looks like AWS access keys and secret access keys. Of course, this is one way to stop your creds getting to places they shouldn't. The best way of actually ensuring this is in the way you set IAM up. Our own recommendation these days, and indeed for a long time, has been when you set IAM up, you give users no permissions at all. You give the groups that the groups that your users are members of permission to assume a role, and then you give your roles the interesting permissions to do relevant least privileged things. So this means that whenever a developer wants to do something privileged, they either need to have a Lambda function or an EC2 instance or a container do it for them by being in an IAM role, or they need to assume the role themselves and go through the process of minting and using ephemeral STS keys. And of course, the key is in ephemeral because if you have ephemeral keys, then this takes away any incentive of a developer to go hardwiring any keys that can do anything useful into their code in the first place. And as we all know, prevention is better than cure. So we've got Git secrets, as mentioned. We also, if you use regular public GitHub, there's a cool blog article, which I rather like, about how you can actually turn a Lambda function into a Git bot, into a GitHub bot. To go and, based on GitHub events, to actually go triggering your own code. So if we now move on to auditing and validation, this is really when we get into static analysis of our code and other interesting things. There's a whole bunch of tools out there now for doing code static analysis, code dependency analysis, and other things. Some of these are tools available on the AWS Marketplace. Others are things that you would want to buy from the vendor and stand up in some reference account that is away from the developer's own control. So they could just essentially wind up calling APIs in order to validate their code as part of the test harness. If you're using tools that you buy from a vendor and install yourself rather than wind up running over the web to a developer's own environment, private link's a great way to actually squirrel these tools away, because what it enables you to do, courtesy of a network load balancer, is effectively extend an ENI from the account where you're keeping your analysis tools into the account where your CI/CD toolchain is. So that way you just wind up being able to make API calls to the remote system just using Lambda functions, provided everything has appropriate routable paths. So I've picked a few examples that I know and like the looks of. Also, these have varying different ways of calling them. So as you can see for Veracode, you just wind up curling the thing in order to invoke it. A thing worth bearing in mind as well is that when you go invoking these tools, you often wind up needing to supply credentials along with that. And this is something I'll be getting into in a little bit more detail shortly. Obviously, a bunch of the tools also have direct GitHub integration. Also, in the context of Jenkins integration, you can't sensibly get involved in a DevSecOps toolchain these days unless you've got a Jenkins plugin, it seems. Although, of course, Jenkins is a bit of a polarizer in terms that I know some people love it and some people hate it. However, it got there first, so lots of people use it. There's open source tooling as well. I see some people using these. To be honest, most customers I talk to about DevSecOps are actually using one of the commercial tools. For container builds, of course, rather than just regular AMI builds, you have further tooling specifically oriented around containers. The deep security guys from Trend Micro have actually built some tooling for their deep security smart check capability, so you can just call it from their Python library and do static analysis of your container configuration, including also looking for malware in your build. But again, from containers, my view is that the best way to avoid malware is to do build from scratch rather than importing everything from something like build from Ubuntu. Now, one thing that we've actually started doing recently, which I admit I'm rather fired up about, who here has actually seen this page that we have put up recently on our main website, Provable Security? Nobody yet. This is really, really neat stuff. The guys in our automated reasoning group, who have also produced the back-end tooling that results in the config rules functions that enable you to determine whether any S3 buckets are world read or world write, have actually opened the lid on a lot of their research. So on this paper, on this page, there's a video from Formal Logic Conference where the head of the team actually presents on a lot of the work. There's also links to about half a dozen papers from learned journals. And one of the really interesting ones, or at least the one that's caught my attention mostly, is this one. Who's familiar with S2N, our own little TLS stack? Just a couple. So we all know what happened with SSL last year, a couple of years back in fact. S2N is our own ground-up re-implementation in C of a very tight re-implementation of TLS 1.2 from first principles. It's written very simply in C, it's well commented. The reason why it was written the way it was written is to make it provable, actually using formal validation. And this is the paper as to how we go about doing this. But one of the things that we've actually managed to do in collaboration with some nice people in academia is we're actually able to do continuous proof on S2N as well as continuous integration. So every time we change the code and then rebuild it, we actually also change the proof and then reprove the new version of the code. I'm pretty staggered by it, to be honest. I think it's really, really neat. And indeed, I actually think the formal reasoning, formal proof stuff that we're working on, from a security tooling perspective, it's not really another tool for the toolbox. It's an entire new toolbox, taking a completely different approach to how security is done. So I've been having a chat with the automated reasoning guys behind this, and if any of you guys are interested in getting into this kind of approach for looking at your own code, as well as obviously those of us who've been around for long enough to have read Don Knuth's disclaimer at the front of The Art of Computer Programming to the effect that I have not tested this code, I've merely proven it correct. Of course, we do both. But this is the book that I've been recommended to read, and it's going to be my Christmas present to myself, and probably going to take all the free time I have over Christmas, because it's about 900 pages worth. So I'm going to be filling my head with this over the forthcoming holidays. So I've mentioned Jenkins integrations already. Find a CI/CD security tool out there that doesn't have one and you're doing better than me. However, one thing that does sometimes plague Jenkins is plugin proliferation. You just wind up collecting plugins, adding them in, and they grow, and the list grows, and it grows some more, and it gets hard to manage. There are plugin managers available. This is a nice one that I found in Devops Weekly. By the way, Devops Weekly, any other subscribers here? Good. It's a free weekly newsletter from a third party, comes out every Sunday afternoon. It's a nice thing to read on a Sunday after the papers and after a nice lunch. I've been a happy reader for probably about 3-4 years now. It's a bag of interesting stuff around tooling and papers and presentations and so forth. There's normally every week at least one good security thing in it. So, for container analysis, I've already mentioned what you can do at build time with Trend Micro's capability. I had a chat with the guy who wrote the integration for Trend Micro's tooling. At the time, it wasn't as well documented as it might have been, but this is essentially the script that he winds up calling to invoke it. And again, as you can see, there's credentials lurking in there. So again, this is something that you want to be going and doing call substitution for. More on that again shortly. On to continuous scan. Once you've built your code may be tight, but what you're linking against might not be. And this is an important realization that the guys at Sneak originally came up with. And they wound up, and White Source do it now too, along with others, for actually scanning your libraries to determine whether there's any CVEs against them, whether you're using the latest versions, or perhaps most interestingly for certain companies, whether the libraries are released under license conditions that comply with your own policy. because I'm well aware that there's quite a lot of companies out there that are perfectly happy with GPLv2, but less happy with GPLv3. So if there's anything that may be a license condition consideration, both of these can flag it. The guys at WhiteSource even have a browser plugin for it. So if you're browsing GitHub or SourceForge or any of the other usual code repos out there, and you're looking at a library that has vulns in it, or is not a latest version, or doesn't comply with your own license requirements, there's actually a little light in the corner of your browser that will start flashing that essentially means move on, nothing to look at here, don't go using and linking against this one. Which of course is a great way to do it because it means that the developer's time is not spent working on a version of a library that just isn't appropriate for them to use. The guys at Black Duck, which got picked up by Synopsys, can also do this as well, but I haven't actually looked in detail at how they go about doing it yet. Checksumming. Once you've gone and done your build, you normally want to go and checksum your asset that is freshly built so that you can ensure continued integrity of it through its life cycle. If you're building an AMI, it's an interesting question as to whether you actually need to be honest. Unless you're actually going to be copying them across multiple accounts and having different entities consume them. Because the thing about AMIs is ultimately the backing store for them is S3. And while S3 is something that most people set up so as to pretend to appear like a file system, in practice it's just a key value object store. And object writes are atomic in nature. So once something's in S3, you can't go doing a bitwise edit on it. You can't change a single file in a posh CPIO ball, better known as an AMI. So you have to do a rip and replace of the whole thing, which then goes and changes the AMI ID. So from the point of view of continued integrity, it's actually one of those nice things where we actually wind up doing that part of the work so you don't have to. If you're building something other than AMIs, of course, you still want to go doing it. And of course, we recommend a nice strong hash like SHA-256 for doing that with. Also, of course, for containers, if you're in a position to sign them, please do. Makes life a lot easier when it comes to managing your integrity further down the line. Once you actually get onto promoting your functions into the places where they're going to live, this is where things get a bit interesting. So, CloudFormation users in the room? Good few, that's nice to see. The thing about CloudFormation templates is they don't just have to be single atomic lumps in terms of single stacks. You can have a master stack that goes and calls multiple other three-tier web architecture where you've got your web servers, your app servers, and your database tier. Chances are the people who maintain each of those tiers, if you're a sizable organization, they're going to be different teams. They're the people who are going to be best positioned. Parameters, your resources and your outputs, which you then slot all your resources into, you run the thing and you get infrastructure out. How about you go splitting the ownership of these, as I said? If you use YAML rather than JSON, other good reasons to use YAML is finally you can comment it, but also if your eyes are as old and not so good as mine, YAML means there's less playing hunt the comma. If you use YAML to bolt all these together, this is something that your continuous integration capability can do nicely anyway, because that's what it's built for. So if you merge your files and then only validate and deploy using Jenkins or your other CI or other CI capability, this can actually do the job for you. So when you're doing your merge, if you think about it, when you put your template together into a file or a stack or a set of stacks, merging the different bits created by the different owners, who's going to own the compound thing that comes out at the end? Security. And the reason you want to go doing this is, again, this winds up automating some sanity checks for you. Once you've got your merged entity, security can then go sticking their own code on the end to test the nature of the environment that the template deploys, so that if there's something about the environment that security wouldn't like, then you can use CloudFormation to fail the template deploy and thereby roll the whole thing back to what should be a consistent state, being at the point before the failed template deployed. So all of a sudden, your deployment automation gets the ability to yank its own and-on cord and roll itself back. You're automating your security testing. This is a really nice way to not get in the way and slow your developers down. So as you can see here, we're just doing a bit of merge testing. We've got some tests that you might wind up tacking on the end of a template. What we're doing here is actually just looking for specific IP address ranges, since almost certainly you're going to have a different range for production versus a test or staging environment. This is to avoid things like the Knight Capital situation, where an environment that is a candidate for test accidentally gets deployed to prod. So if you're filtering to ensure that only staging is an allowed environment for deployment, anything that might accidentally, through an admin's fact fingering or whatever, attempt to get deployed to prod isn't going to happen. It's going to detect that it's going to prod and it's going to yank itself. Also, of course, a CloudFormation template, let's not lose track of the fact that ultimately it's just a text file. So you can go grepping through it for things that you might want to not see and alter. So again, we've got a little bit of Ruby here. Again, it's looking for specific IP address ranges. If you were to use this as a filter as part of the process before the template even gets run, you could stop it getting run and therefore needing to yank itself. There's multiple tools that you can use for this. Obviously, step functions these days can be easier to set up than a simple workflow. So let's look at our structured deployment. We've got our different entities building our templates. So we've got the infrastructure team owning the base skeleton. We've got our DevOps team adding assets to it. Security goes and runs it, gets stuff out. If it doesn't like what it gets out, it immediately gets respun backwards. And in terms of doing this, we've spoken about being able to do this with CloudFormation for AMIs and other entities that can be deployed with it. Obviously, you've got EC2's plan capability for sending Docker images out, and for OS packages or arbitrary files, you've got code deploy. All these are essentially just tools for getting stuff to places, and all of them actually have the same rollback, the same graceful rollback capability that CloudFormation does. So this actual model of doing the ownership change, have security TAC automated checks on, and then deploy, it's generalizable across multiple tool sets. Now, if you're doing continuous deployment, I reckon that you need to be doing continuous penetration testing as part of that as well. It comes along as a necessary element. And unless you're going to be actually deploying to containers, which you then do separate testing on, I came up with a little architecture a couple of years ago for actually automating this. I'm going to walk through it a little bit. I don't have long enough arms to stretch between both screens, so I hope you're all able to see this one. It also gives you an example of how an AWS CI/CD pipeline works. So we have code commit here. Our developer pushes code. It goes into code pipeline, triggers code pipeline. From there, you can run some tests to determine if there's any CVEs against the code as it stands, by running it on an EC2 instance that is instrumented with Inspector. Another useful thing, by the way, if you go and get formal external penetration tests done, you want to go instrumenting your targets with Inspector, because as your instances are getting effectively attacked, you can get useful information about the behavior of your software while it's under attack, and that adds value to what you're getting out of a pen test report, because some transient things that can go wrong with your code under attack, Inspector will pick up, but a formal pen test might not, again down to their transient nature. So as part of your code pipeline, let's say you're doing code deploy to then go and push to a staging environment up here. One thing you can do with code pipeline, which came along a few months after it originally launched, is you have the ability to launch a Lambda function. So let's say that you have some arrangement with either an internal or external pen test as a service provider. We've got some customers back home in the UK who've actually got this built and working with their internal pen test teams. Let's say these guys have some static website somewhere that gives you a menu of the kinds of tests that they'll run. Since obviously their stock in trade is having interesting attacks that they'll keep as an asset set and a custom AMI that keeps them 3 or 4 steps ahead of what you'll find on Metasploit. So in your Lambda function, you can construct what's effectively a job file listing the attacks that you want them to run, giving them details of what it is they need to attack, whether it's attacking through an ALB or whether you've just got bare instances out on an internet gateway, and also give them information on where to go putting their report. So you normally give them something like a one-shot signed S3 URL that they can write here. So call them through API Gateway. They can then go unpacking your little job spec, put some information in DynamoDB from the point of view of CRM or whatever, probably kick off a billing cycle based on this if they're external, or indeed they could put this on the AWS Marketplace and charge per API call invocation, and then go put your job on a queue. This could actually do with a little bit of updating now. I think I've got a slightly better way to do this bit, but if you have an EC2 instance essentially orchestrating all this and monitoring your queue for depth, then when there's new jobs in the queue, if all your attack instances are busy, it can go launch a new one from your AMI with your proprietary test suite in. Now, a thing about getting pen test authorization done in AWS, it's really, really important that we get information about what IP addresses the attacks are going to be coming from. So in order to maintain consistency for that, for a pen test provider, they want to be maintaining a pool of static IP addresses that you can then go put in your pen test authorization request. So one of those will get attached by your master instance when it goes spinning them up. It'll pass probably as user data information about what attacks are to be conducted. The attacks get conducted, and then you wind up with a report, which is probably just a console log dump from your test tools into the S3 bucket. At which point, you've now had an object write event on your bucket that can go triggering a Lambda function. If as part of your job spec here you include information about the code version that you're testing, then you can also go grepping that report to say, for this code version, were there any fails? If there are any fails, then you could do something like post to an SNS topic that the software version maintainers are subscribed to say, the test failed, this is what went wrong, etc. Whereas if there are no fails, then you could actually, from this Lambda function, kick off another code pipeline to take the code version that's passed its pen test and push it into production. Abracadabra. As I said, there's people actually doing this. If we now get a little bit meta, Lambda functions are great. We all like them. You need to consider the security of your functions themselves. Security is not only all the way down, it's all the way up. So if you're going to be calling any third parties, you obviously need to do due diligence on them, especially if they're going to be seeing important things like your code from the point of view of intellectual property. There was a really good session that Guy Pajani from Sneak gave at ServerlessCon back in 2016. I would definitely recommend going and reading his slides. He says a lot of good stuff in there. So, good practices for Lambda security: one function, one purpose, one IAM role. The thing about Lambda is it's almost too easy to start standing up sets of functions, linking them together, and doing stuff. And there's still no substitute for good design. You need to be really careful that you don't get very enthusiastic and write a ton of functions that essentially wind up being a big hairball of code, and you then need to do to go through some kind of HTTPS proxy. I'm a Squid fan, others are available, so that you can actually do filtering as to what the endpoints are. These are the kinds of constraints that you can't natively apply to a Lambda function that's running outside of a VPC. Obviously, for Lambda functions that do run inside a VPC, there is a performance overhead when you're doing a cold start, because the ENI has to get created and get attached and so forth. And this can be as much as seconds, which, as you might expect, is anathema to my DevSecOps loving serverless friends. But in terms of how that may get fixed, I'm afraid I'm just going to have to sit here and try and look as enigmatic as I possibly can, because hey, it's reInvent in a few weeks. Watch carefully. Also, who here's seen PureSec or Protego and what they do? Just one at the back. A couple of startups in Israel, really interesting stuff. And I would definitely recommend looking at both of them, actually. PureSec have been around slightly the longest, and they actually do have customers running in production. What they have as their principal commercial product is a library of code that you link against and include in your zip bundle of Lambda function when you upload it. It's a few megs worth of code, and at start time, it imposes tens, maybe hundreds of milliseconds maximum overhead. The best they've actually seen is 50 microseconds themselves. But what it enables you to do is to actually have an application level firewall inside your Lambda function. And this means that you're not only able to effectively have an outbound WAF inside your Lambda runtime environment, but it also works very much like AppArmor does on regular Linux, in that you can control which functions, which tools in the Lambda runtime your own code is able to actually invoke. I wouldn't say it goes quite as far as SE Linux, but it's definitely AppArmor-like. They also have a couple of neat tools on their open source GitHub repo, one of which I think Lambda function writers among you will really like. It's called PureSec CLI, and what it does is if you give it your Lambda function code, it then gives you, again, it's one of these things that you run locally, it's not like it's sending code back to them. It gives you a least privilege IAM role that your Lambda function can run in. So it saves you the trouble of crafting your own least privilege IAM roles for your Lambda functions. They've also got a new release involving 4 config rules regarding, again, their own recommendations for Lambda function configuration. Recommend you take a look at them. Protego are looking at the same kind of math, but approaching it from the other direction. These guys are looking more at what happens in terms of how fleets of Lambda functions behave. So if you have a Lambda function that's really hot, obviously Lambda will go and clone another version of it so that you can have, before you go raising any limits, up to 600 concurrent versions of the same Lambda function. All of a sudden, you've got a fleet here, and you can do behavioral analytics on that. And you can see if one of these Lambda functions, for example, gets hacked in the 5 to now 15, of course, minutes that it's running, whether it starts behaving oddly in terms of calling other things, consuming extra resource, so forth. So if you get to the point where one of these things is not behaving like the others, Protego can actually alert you about this. You can set it up to automatically kill the rogue implementation of the function. It's useful. Again, both tools well worth looking at. Now, I said I was going to talk a little bit about credentials management. We have two options. One is Secrets Manager, the other is Systems Manager Parameter Store. And there has been a bit of confusion as to which does what and which is best for what purpose. If you're doing stuff at a CLI level, then Parameter Store is probably your best bet, because it allows you to very simply and very transparently substitute credentials for pointers to them in a command line. So in the example I was showing you earlier, where you wind up curling a source checking tool, you could just have that curl first go to SSM and do parameter substitution. Both of these tools, by the way, you can put up to 4K's worth of secret in them, which is plenty big enough for a private RSA 2048-bit key. And I actually use the parameter store quite a bit for braining Apache instances with key material. You wouldn't necessarily want to go putting a fully pinned certificate chain in there, of course, because it would overstretch the bounds. Secrets Manager is better if you're doing stuff programmatically. It can actually emit sample code for you that you can substitute for the code you normally use, where you need to go reopening and reading a carefully protected file somewhere that's got a clear text password in it. And also the thing that Secrets Manager will do for you that Parameter Store won't is if those secrets are used as credentials for accessing AWS services, so things like database passwords for accessing RDS environments, then we can actually auto-rotate them for you, which is really fun. And again, as with many of our tools, this is a customer-facing respin of a tool that Amazon's been using internally for years. So it has been battle-tested from the point of view of you not getting stray connection drops based on credential timeouts. Essentially, there's stuff that goes on involving creating new users and then flipping the user profiles over. It works, put it that way. So anyway, onto a little bit of detail with Parameter Store. You don't need to give many further IAM permissions in order to use this. Both Secrets Manager and Parameter Store encrypt their secrets in the back end with the KMS key of your choice, so you can keep your secrets nice and secure. And obviously you need to give your key a policy so that it can be used. So if I start off by putting my RSA private key into Parameter Store as a secret, I'm using the secure string type here to say use KMS, and I'm giving it a KMS key ID. I can then, in my EC2 instance, which is going to be an Apache server, just have a little cloud init script that goes and does a send command to Parameter Store to cat the substituted key here. So the substitution is done with double curly brackets. So it'll take what's actually in my private key, cat it to all the usual places where I would expect, to the usual place I'd expect my key to go, do the usual chmod and chown on it, and then my Apache environment can start up pre-brained with a certificate and key pair. I'm reasonably happy actually putting my certificate in my AMI. Others might not be. You might want to go fetching it from S3. And indeed, if you're going to have a long-lived AMI, that would be the better thing to do, so that you don't have a situation of needing to recut your AMI when your certificate expires. So from DevSec onto a bit of SecOps. Logging and alerting. The thing about AWS, one of AWS's really big strengths, is my favorite idea of a logging policy is if it moves, log it, and if it doesn't move, watch it till it moves, then log it. And it actually isn't that hard to implement something like that in AWS. So CloudWatch events is probably the most popular new logging capability to look at, primarily because of its low latency. We built it ourselves in order to cut down on latency in things like CloudTrail, and it actually gives you a lot of data in a log record. It's also highly supported in terms of the number of services. So in terms of actually setting it up, for those of you who still use the console, it's dead easy. So create your rule, pick it up as being an alert on an API call. Let's say we want to stop someone turning CloudTrail off, which these days I would do with an SCP, but we want to have this as defense in depth. So we pick on CloudTrail, we pick on the two calls that we want to stop, in particular in this case, stop logging and delete trail, and we pick a Lambda function that we want to actually trigger when we see those events. In terms of what the CloudWatch event record looks like, that's a fairly easy thing to dump, and it looks like this. The interesting stuff happens in the latter half of the actual record. So as you can see, Bob, our hapless intern, has tried stopping CloudTrail. So he's run stop logging, he's run them with his own keys, and as you can see from the invoked by here, signin.amazon.aws.com, he's invoked it from the console. So we've actually got a bunch of info here that we can parse and do something useful here, like turning CloudTrail back on. Obviously, another thing that we want to do is once we've actually done this, we want to inform our friendly security team that this has fired and something useful has happened and they don't need to worry. So we can just send the details to an SNS topic, which can get picked up by SES and email them the details. And then, of course, your function is going to log the fact that it has run. In terms of pre-built frameworks for doing this kind of stuff, who here's come across Cloud Custodian? A few, okay. Very useful framework written by people at Capital One Bank. You can either take the framework, customize it, deploy it as it is. It's on GitHub, so it's fully open source. Or even if you want to do your own thing, it's still actually a good source of Lambda function code that you can borrow from. Now, one thing that gets interesting, especially if you're doing multi-region stuff and looking at shipping your logs into one consolidated bucket from around the globe, is there are certain regulations, which I shall not name here, but I expect you all know which they are, that take a bit of a dim view about shipping personally identifiable information out of certain regions and into certain other regions. So how do you go about dealing with this? This is actually true story here. I actually had a discussion with a bank who shall remain nameless. They wanted to put a PCI DSS workload in AWS, which lots of other banks run. And they had a very diligent and rigorous QSA, PCI auditor, who said to them, okay, so, well, I'll just walk through this bit first. So if we've got our AWS account here, we've got our CloudTrail and our config records coming into an S3 bucket. We've got an EC2 instance, which is running the CloudWatch logs agent. It's being monitored. We can actually go and have a Lambda function take the log records out of the CloudWatch queue and drop them into that bucket as well. Now this QSA said, okay, if I'm going to take the contents of this bucket and I'm going to ship them out of the account, hang on a minute. If these instances are processing card data, then what happens if these instances were, for one reason or another, to come to misbehave? So you've got your CloudWatch logs agent up here. Let's say the card data got catted into a log record that the CloudWatch logs agent was scraping. All of a sudden, we have a signal path here for that card data to end up in this bucket and potentially escape our PCI boundary by getting shipped not only potentially cross-account, but also cross-region. This is a bad thing. Show me what secondary controls you've got in place to stop this happening. And the bank went, oh, Dave. As it turned out, we did a fix for them involving something very, very hackish and SE Linux, but we figured afterwards there had to be a better way to do it. So we did satisfy the QSA, and we figured that the thing to do, so again, obviously you still have the ability to trigger other Lambda functions off the CloudWatch events. but we figured there had to be a better way of doing it. So how about we put a Lambda function here, and in that Lambda function, we can actually open up our log records, we can grep through them, and fortunately, things like card data is easy to tie up with a regexp. So you can spot it, you can replace it with asterisks, you can scream over SNS sensitive data has found its way into our log system and shouldn't have, and this should satisfy a diligent and rigorous auditor that you've got a secondary control. At which point, you can then ship your data redacted as needed, cross-account, cross-region to where you're keeping your logs. Now, you can apply this principle to other kinds of sensitive data as well, such as PII, although, of course, that gets a little more interesting to grep for. There is an infamous regexp for actually picking up what constitutes an email address. You can go wiring those in. If you're using regexps that, again, are interesting and complicated, you may want to actually, bearing in mind also the idea of one Lambda function, one IAM role, one purpose, you could also chain things together. So you have your bucket here with your unredacted data in, you have a Lambda function that just does your redaction and drops the redacted data in another bucket here so that you can check it, and then you just have another function here that does the shipping. You take it whichever way you choose, but both work. We have some sample code. It isn't public yet, but we're working on it, to actually go and do this. It's relatively straightforward. It doesn't involve many IAM permissions. We're going to try and see if we can get it out for reInvent, but no promises. In terms of actually making, obviously we've seen a bunch of Lambda functions all over the place. Some of these are in developer accounts. We're using Lambda functions to mediate and manage our logging. We don't want our developers in their developer sandbox accounts, where again we still need to be logging because we want to ensure that they aren't doing things they shouldn't be doing on our time and money. How do we stop our developers going and messing up our logging environment? There's a few options. It depends on whether your developers are writing Lambda functions or not. If they're not, it's actually easy. Who here is using organizations and SCPs? My single favorite feature in all of AWS, but part of that is down to the fact that I've spent long enough doing mandatory access control systems in interesting places that it sort of worked its way into my head and stuck. SCPs, however, I'm a huge fan. What they enable you to do is to prepend another element of policy that looks very much like an IAM policy onto the effective policy on users in member accounts in an organization, such that the extra prepended bit of policy is both invisible and immutable to all to all users in that member account, including root, and applies to root as well. So all of a sudden, root is no longer classic Unix omnipotent root in an IAM member account in an organization. And I'm writing a little library of these things, blowing my own trumpet a little bit, but I've got some samples in my reInvent session from last year, and there's more coming in this year's. Guard duty, who's using it? I hope at some point to see everyone's hands up for this one. Threat intelligence as a service. Again, from a DevSecOps perspective, it triggers CloudWatch events that you can act on. So it, by default out the box, it picks up data from Proofpoint and CrowdStrike, and also from AWS's own threat intelligence service, because it's a not very well kept secret at all now that we actually have honeypots seeded through the EC2 fleet that we manage and monitor ourselves, so that we can determine what the latest things are that bad people want to hit them with. And from there, plus the combination of data that is also exposed to you normally via CloudTrail and VPC flow logs, plus VPC DNS data, which isn't surfaced via any other means at this point, Guard Duty can actually give you information about a whole ton of potentially bad things that might be going on inside your accounts. There's a set of findings that Guard Duty has. So, for example, in a kill chain, it can pick up and actually detect all these things. One of the particularly popular ones that I started getting asked about just after Guardrail got released was DNS exfiltration. And there's been a lot of work put into that, particularly using machine learning on the back end. This list is always incomplete because the Guard Duty team, bless them, just keep adding new findings. They're up to 46 now. The URL at the bottom is the only list that you should actually consider definitive. Another thing that we're doing is, as I said, you wind up getting CloudWatch events off of this, which you can just go doing static analysis on the rules, just doing pattern matching with CloudWatch alarms. Or indeed, you can go feed things into a Lambda function that could go and post them to the human consumption mechanism you're choosing. We have a function on AWS samples that will post to Slack. Guard Duty also gives a numerical priority severity on its findings. So a common thing that we see among customers is low priority stuff goes to a Slack noise channel. Medium priority stuff goes to a Slack channel that the admins are actually paid to look at, and anything that's particularly high priority gets people out of bed. But again, the code's there. It's free. You can rip and replace the Slack integration with whatever integration you choose. The nice people at Trend Micro have also released a set of tooling on their deep security account, which, if they see a Guard Duty finding coming from a specific EC2 instance, they can go and run a check on that EC2 instance to gather more detail automatically about how it's misbehaving and potentially do some auto-remediation on it. In terms of dealing with all these different findings, one thing that we've been looking at, there's a few initiatives internally about constructing sets of Guard Duty responder functions, as well as actually Guard Duty alerter functions. That, again, is work in progress. I'm afraid I don't have a time frame to give you on it. In production environments, of course, ideally, and certainly what we managed to do, you want to get to the kind of security nirvana where a production environment is never touched by human hands. And there are means of actually doing that, in that if we have our classic multi-account environment here, one thing I'll be talking about in a bit more detail at reInvent, when we have a customer with a central directory of stuff, they're normally not happy about turning that into an IDP and going and plugging it into the internet, because this essentially is their crown jewels with all sorts of enterprise integrations and credentials of everybody up to the CEO in it. A very common thing is to stand up a separate IDP server that only actually has partial replication to it of the groups of users who are going to be interacting with AWS APIs. And they often wind up going and putting firewalls and proxies and so forth in the way to give themselves a trust gradient. Now, if you've gone and done this, it's actually relatively easy to do it again. So you can have separate IDPs for production and non-production environments. And what this means is that in the same vein that you would normally have bastion hosts that you keep turned off in normal operation and only turn on in emergencies when you need to SSH into something in a production environment to see what's going on, debug something, etc., you could actually take your production IDP server and turn it off in normal operation, thereby denying humans the ability to make API calls into your production environment, and just have Lambda functions and other automation do that for you. Because while we want to keep humans away from data, let's not lose sight of the fact that it's by use of APIs that humans gain access to the data in order to mess it up. And there's a lot of stuff that's been built around responding to this in more subtle ways than you can currently do with IAM. So again, case in point, our hapless intern, if he goes launching an EC2 instance in a particular subnet and a particular set of security groups, that goes and creates a CloudWatch event, which can go and kick off a Lambda function responder. That can go and check whether the combination of AMI and security group and subnet is appropriate according to your policy. You wouldn't want to go hardwiring your policy into your Lambda function to do this, so you'd probably go and keep it in DynamoDB, giving lists of which combinations are valid. If there isn't a valid combination, then from your DynamoDB stream, you can kick off another CloudWatch event, which then goes and kicks off another Lambda function that goes and kills the instance. Obviously, there's a bit of a race condition going on here, but bearing in mind it takes an instance typically 1 or 2 minutes to come up, you're going to have killed it before it's ever actually bound a listener to a port. And finally, bearing in mind I'm actually bang out of time, who here is using our WAF? Just a couple, okay. It is fair to say that, well, from the point of view of WAF, do you want to go putting it in front of Lambda functions or not? You actually can, but if your Lambda functions are processing HTTP, HTTPS and are internet facing, then it might be a good idea. Otherwise, to be honest, there is no reason to. However, a friend of mine back home, Lee Atkinson, produced an interesting model involving Lambda and WAF interaction, and it's posted on our GitHub AWS Labs account under CloudWatch under WAF integrations. Sorry. So what you can actually do there, what Lee did, is again really rather interesting. So the code's available. So if you set CloudWatch up to do cron-style triggering of your Lambda function, then you can go off to Spamhaus or the other real-time black hole list server of your choice, grab their list of threat actors, their list of bad IP addresses, transcode that into a set of AWS WAF rules, and push it forward. So you've actually got a nice baseline in your WAF blocking bad actors against CloudFront before they even start doing anything, or before you even start constructing more sophisticated rules. This is something that I know some customers are running, say, a few times a day. I know some who are running it as frequently as every hour. A further thing that you can do, and again this is where Trend Micro come in, is they actually have a means whereby their deep security product, when it characterizes badness, it can synthesize a rule for the AWS WAF and push it forward. And again, that's a popular model, so that you have a smart but relatively small third-party head inside your environment doing your traffic characterization for you, and then pushing brute force block rules to a set of broad AWS shoulders out at the edge to block the attacks as close to the attacker as possible. This deals with some things that some customers aren't keen on with managed WAF rules. Some customers are perfectly happy with managed WAF rules, others would like to see a lot more detail. And the thing about managed WAF rules is it's a black box and you can't actually see what the rules themselves are. But this is a good way to baseline your WAF. It's a nice simple function. In terms of reference, a whole bunch of links, including some stuff from PureSec and Protego. They're getting prolific with white papers now. They've got PureSec have got a good one here that's very OWASP-like about what the top 10 things are that can go wrong in serverless function programming. It's a good read, and how to put them right. If you haven't read it already, I think the Devops Handbook is very much a page-turner, as it's mostly case studies. It's not the right time of year for it, but I would say it's actually beach holiday reading. And finally, there is Devops Weekly, as I mentioned. Nice free newsletter, comes out every Sunday afternoon. So, thank you. Hope that's been of interest.